All right, so this is the review guide for the midterm. So for number one, it says, what's the equation for y equals absolute value of x minus 1 plus 3 reflected across the y-axis? So we can make a little sketch. Again, you can graph this in your graphing calculator if you want. But here we've got plus 3, so this is telling us that we got to go up 3. So 1, 2, 3. And then with x minus 1, so we know that we have to go 1 to the right. All right, so with a V shape, so if I want to reflect this across the y-axis, we want to remember that the y-axis is this one right here. So if we reflect this one, we should end up with a point that is exactly the same distance away as our vertex right here. We should pass through, and we should look like this. So that's kind of the idea, is we want to come up with a graph that looks like that. Now, there's a couple things that we could do. Now, we could take this and we could say, well, it looks like it's just going to be plus 3, and then instead of minus 1, we could do a plus 1 here because we could move it to the left. So that would be one option. So x plus 1 plus 3, because we would go, instead of to the right with the minus 1, we could go to the left with the plus 1. But with absolute values, there's actually a little bit of a weird thing that we could do. And we could actually go y equals negative x minus 1 plus 3. So we could actually do a reflection. Technically, a reflection would be switching x to negative x. So we could also do this. Now, the thing that makes this kind of weird is if we do factor out this negative sign, we would get absolute value of negative x plus 1 plus 3. And the absolute value of a negative would actually get us back to what we would do if we would just move it over to the left. So that's kind of cool that we have two different ways to do this one. Again, both ways are pretty good. If we wanted to double check, we could always make a graph and double check and just see if our graph looks the same. So I'm going to throw it in. We'll see what it looks like. So we've got absolute value of x plus 1 minus 3. That's the wrong way. That's our original, x minus 1 plus 3. X minus 1 plus 3. And then what we can do is we can switch it either with a plus 1, and we can see we do get a reflection across the y-axis, or we can just switch this x to a negative x, and we do end up with the exact same graph. So it's kind of cool. So that's how to do number one. That's all about the transforms from before. So number two, identify the translations of the parent function. F of x is x squared. That gives us g of x is the quantity x minus 8 squared plus 7. So here, again, we can clearly see this is going to be up 7. So let's go ahead and get rid of these ones that say down 7. And then for minus 8, we have to remember that minus is the opposite. So we might think left, but the answer is right. So we're going to go to the right 8, which is going to be B. And so that's going to be our final result. So that's all we want to do. Again, you can graph that in Desmos if you want to graph that compared to x squared, but a little bit easier to use the transforms. 3, which ones are arithmetic? So remember, for arithmetic, we need to have a common difference. So in order to find a common difference, what we want to do is subtract everything to see if we're always subtracting or adding the same amount. So if we look at A, if I've got 1 and 1/2, so the difference between that, 1 minus 1/2 is a half. Then if I do the next set, 3 halves minus 1 is 1/2. Then if I do the last set, 2 minus 3 halves is a half. These are all the same. These are all 1/2. So this checks out. So I'm going to pick A because those are all 1/2. I'm adding a half every time. For B, I mean, we can clearly see it's not going to work out because we're switching signs, but let's just, for the sake of argument, go through it. 6 minus negative 2 is 8. And then negative 18 minus 6 is negative 24. So those are not the same. So right away, we can get rid of B. If we want to check out C, here we got to do 48 and 37. So 37 minus 48 is negative 9. That's not negative 9. Oops. That'd be 39. Negative 11. So we're going down by 11. The next set then is 26 minus 37, negative 11. And then the final set, 15 minus 26, is also negative 11. So this way, we're going down by 11 every time. Since we're going down by 11 every time, we do want to pick C. Last one we got here is D. So again, pretty clearly it's not going to work out. But just to show, 1 minus 1/3 is going to be 2/3. And then 3 minus 1 is just 2. So this isn't going to work out. So that one also does not work out. The bottom two end up being geometric, but we'll get to those in the second half of the class. All right, for number 4, we're at the first 4 terms of this sequence. So we have to remember our sequence with our piecewise notation. So we start at 7. So that's first. And then the instructions say minus 4 every time. So 7 minus 4 is 3. 3 minus 4 is negative 1. Negative 1 minus 4 is negative 5. And that's it. We got 4 terms. We just had to get 4 of them. So we're all set. Next, for number 5, we've got 12 chairs in the first row. Each row has 3 more chairs in the previous row, and there are 13 rows. How many chairs are there in the concert hall? So since we know how many rows there are, this is pretty well set up to be a sigma question. So we're going to use our friend sigma. So we'll say sigma for n equals 1. We need to get up to 13 rows, so 13 goes on top of sigma. And then in here, we always have our formula. So our formula is going to be A1. So I got to find A1, which is 12 chairs in the first row. And then we do plus parentheses n minus 1 times, and we got to find D. In this case, D is going to be 3 more chairs in every row. So that's what we've got. I'm going to write that in general form over here, just in case we want to study the form. N equals 1. Well, general form, we got to use the i's. I equals 1 to n. A sub n plus n minus, this is an I. Forgot we're switching with the i's right here. I minus 1 times d. So that's our general form. Now, again, since this is just going to be a sigma question, we can just throw this into our calculators to figure it out. So we want to go the sum from 1 to 13. I think it was 12 plus n minus 1 times 3 to give us 390. Let me just double check to see those are correct. 12 and 3 and 13. Everything looks good there. So 390 is our answer. Actually, I'm going to steal this one. Oops. I think it'll be a little bit better if we just grab it as it looks. That way it's kind of saved with both the Desmos formatting, most people are going to choose to use, but also with my handwritten part. So 390 seats. All right, for number 6, use a graph to solve negative absolute value of x minus 3 plus 5 is less than or equal to 0. Our graph will be scored. So we've done these ones before. So we know that if we have rectangles, then we obviously did not do anything right. That would be a bad decision. So make sure you don't have rectangles. What we want to do is split it up into 2 parts. So the first part is going to be negative absolute value of x minus 3 plus 5 is less than or equal to y. So I know I've got a solid line because I've got the little or equal to sign. So I have to go up to 5. So 2, 4, 5. We're counting by 2s on this coordinate grid. And then we have to go 3. So we have to go 3 to the right. 2, 3. So we have to go 3. So let's get rid of this point. And then out front, we've got negative 1. So that's kind of like my slope. So my slope on the right side is going to be negative 1. So here I'm at the point 3, 5. So that means I would need to go over 1 and down 1. So I need to go to 4, 4. And then that kind of shows me what my graph is going to look like. I'm going to hit each of my points. Over here, I would go to 2, 4. Go on down. Is that going to be good enough? Let's keep going. I got the space. All right, so now we see that this has to be less than or equal to y. So if I'm doing it by hand, I'm going to pick a test point. I'm going to try 0, 0. If it works, I'll shade in this part under here because that's where 0, 0 is. If it doesn't work, I'll shade up top. So we've got negative 0 minus 3 plus 5 is less than 0. We'll see if this is true. Negative 3 plus 5 is less than or equal to 0. Negative 3 plus 5 is less than or equal to 0. 2 is less than or equal to 0 is false. So I know I've got to shade this part. Okay, so now I got to do the second part. Second part is just this less than or equal to 0 part. So if I write the equation for that, that's just going to be y is less than or equal to 0. Okay, well, that's pretty easy. We're just going to go less than because it's just a straight line at 0. And less than means we have to be underneath it. So I'm going to shade below. So my final answer is going to be all the double shaded spots. So if I look at my double shaded spots, that's going to be all of this section. So everything over here. And then also over here too. So this would keep going down. I would be going this way. So this part also is double shaded. So those would be my two answers. I do have to actually give an answer. I have to give a solution. So I look at my x values here, and I go from negative infinity over here until I hit to negative 2. So negative infinity to negative 2. And I've got another solution over here. So 2, 4, 6, 8 until I go all the way out to infinity. So 8 to infinity. So I get two answers for that one because there's two sections that are shaded. That's what I've got for number 6. And if you want to double check that with a graph, you can double check that with Desmos. All right, let's put it in. Let's see what it looks like. Negative the value of x minus 3 is 5. I had 0. It's less than or equal to 0. Less than or equal to y. And we can see, yep, all right, that looks pretty good. See, I got my point, negative 2, 0, 8, 0. And we can see that those two sections on the edge, where's my camera at? On the edge, those are definitely going to be the double shaded sections. So, yep, that looks pretty good. So I'm pretty happy. Double checked it, looks good. All right, number 7, solve the system of equations. You can solve this however you want. This one looks like we could do a little bit of eliminate. I just like elimination, so maybe we do elimination. Maybe we subtract everything from both sides. These two both are equal to y, though, so it could be a substitution. I also see I got a 2x squared and just an x, so maybe with an x squared and an x, maybe even graphing would be the best choice. I don't know. So we kind of got our options. So I think I'm going to go ahead and choose to set them equal to each other. 2x squared plus 1 is equal to negative x plus 2. And I can do that because these are both y's. For a quadratic, we have to get everything on the same side. So plus x and minus 2. So 2x squared. The plus x doesn't combine with anything. So plus x. 1 minus 2 is negative 1. So now I'm equal to 0. I might have chose the wrong choice because now I got a 2 in front. So I have to do a t-chart of things that multiply to negative 2 and add up to 1 because I got 1x right here. All right, well, that's 2 times negative 1. That's not too bad. So 2 plus negative 1 is 1. But I'm not allowed to jump to my answer because I have a 2 out front. So I have to keep going. I have to actually do my full process. So that means I have to rewrite this as 2x squared plus 2x minus 1x, because I picked 2 and negative 1, minus 1 equals 0. I got to do my first two and find out what's in common. So those both have a 2x in common. So 2x squared divided by 2x is x. 2x divided by 2x is 1. In the back here, these are both negative. So we can plot in minus 1. Negative 1x divided by negative 1 is x. Negative 1 divided by negative 1 is 1. And then I can see, oh wait, now these two are the same. Perfect. That's exactly what we want for this form. So we get x plus 1. And my leftover pieces, I've got a 2x out front and a minus 1. Still equals 0. I definitely feel like I made the wrong choice. I feel like the graphing would have been better here. But we're already here, so we may as well keep going. So I'm going to take this x plus 1. And now what I need to do is I need to do x plus 1 is equal to 0. So minus 1 both sides. X equals negative 1. And now that I've got x, I need to take my x, plug it in to get y. So y equals negative 1 plus 2. So y equals 1 plus 2. Y equals 3. So I finally get an answer. Negative 1, 3. Okay, and I can double check. If I plug negative 1 in here, negative 1 squared is 1, times 2 is 2, plus 1 is 3, so it does work in both equations. But I'm not done. I got a second set of parentheses over here, so I got to do one more set of parentheses. 2x minus 1 equals 0, plus 1 both sides, 2x equals 1, divide both sides by 2, x is equal to a half. All right, and we got to do the same thing. We got to take our half, plug it in for the x, y equals negative a half plus 2, y equals 1.5. So my other answer should be 1/2. I guess 3/2. It's a little bit weird to mix the fraction with the decimal, but looks okay. If we check it out, 1/2 squared is a fourth. So a fourth times 2 would be a half. Half plus 1 is 1.5, 1.5. So that works out. So yeah, that's the way I chose to do that one. I chose to do that one by hand. Again, hindsight, probably would have been easier to do it with a graph. So let's check it out with the graph as well. So y equals 2x squared plus 1. And y equals negative x plus 2, I think it was. Check those. Yep. Okay. And if we look at our solutions, yeah, I get the same answers both ways. Again, maybe this would have been a little bit easier to do at first, but I kind of like doing it by hand, so not too horrible to do it by hand. Definitely easier, I think, with the graph. If I had to pick on the test what to do, I would probably pick the graph. But you do have to make sure that you type it in perfectly, so you have to double check to make sure that it is right. In this case, we want both the x's and the y's because we have both x and y in the original equation. Remember, if there's only x's in the originals, then you only want to give the x's. All right, number 8, write a matrix that represents a system of equations. Well, this one's pretty fast because we just have to write the matrix. We don't really have to do anything with it. So that's going to be 2, 3, and negative 8 on the top. And then on the bottom, negative 4, negative 5, and 1. That's it. So we're already done with that one. That one's pretty quick. 9, write the reduced row echelon form for the matrix. So here we got to do some RREF. I should have loaded up the matrix calculator, but we'll do that right now. Calculator, because we have to plug this into the matrix calculator, and then we'll do the RREF. So I want a new matrix. I want to make it a little bit bigger. And let's see my numbers. 25, negative 5, 1, 10. And second row, 9, negative 3, 1, 2, 3, 4, 2, 1. This is actually a negative 3. All right, lock that in. We're going to do RREF, so we'll do RREF of matrix A. That looks pretty interesting, so that doesn't look too good. Let me check out my things. If I do a fraction, I got sevenths. I don't know if sevenths is right. Let me double check to see if I plugged everything in right. 25, negative 5, 1. Oh, yep, I need to do a negative 10. Okay, now I got all whole numbers. That looks a little bit more familiar compared to what we've been usually working with. I think I'm pretty happy there. Let me just double check again. 9, negative 3, 1, 2. 3. All right, pretty good. So again, I saw what I messed up and I fixed it. Same idea we want to do when we're taking the test. Probably don't need that negative 10 underlined to show how bad I messed up, but that's okay. So final answer, since we're writing the row reduced echelon form, we do want to write this as the answer. 1, 0, 0, 0, 1, 0, 0, 0, 1, negative 1, negative 2, 5. And that's it. We're all set. That's what we got for number 9. Number 10, what's the equation in vertex form with the parabola vertex 3, negative 3 that passes through 2, 9? So we can see right here now we've entered into Unit 2. So those past 9 questions all kind of came from Unit 1. So we got to do vertex form. So we have to use our vertex form. So y equals a x minus h squared plus k. All right, and we plug them in. So we have to remember this is h and k. So that's the first thing that we plug in is the vertex. Y equals a, x minus 3 is h squared plus negative 3 is k. Next thing we have to plug in is this point. This is actually h comma k. A little bit weird. It got kind of thrown off. Probably would be nicer if it was all in one line. That's not h and k. That's x and y. Let's fix that up. So 9 is y. A2 minus 3 squared. This is plus negative 3, so I'm just going to write that as minus 3. And now we're in our usual idea. We want to try and solve to figure out what a is. So that's what we'll do. We'll try and figure out what a is. So to figure out what a is, first thing we want to do is just add 3 to both sides. Pretty nice. 9 plus 3 is 12. 2 minus 3 is negative 1. Negative 1 times negative 1 is 1, so we can divide both sides by 1 to get 12 equals a. So final answer, we'll come back right here. Y equals 12, x minus 3 squared, plus negative 3 or minus 3. And there we go. So we're all set. If we want, we can double check it by graphing the answer and making sure that both of our points do pass through. All right. Number 11, we got another transform question. G is a transform of x squared. G is a translation right 4 and up 2. Write the equation in standard form here, ax squared plus bx plus c. All right, not too bad. We have to do the same thing we did on the last one, x minus h squared plus k. In this case, we're given no information about any vertical stretch, so a is going to be 1 in this case. We're going to go for right 4 units, so that means we'll plug 4 in for h. We're going to go up 2 units, that means we have to go plus 2 for k. Almost forgot my little squared. Since I'm multiplying here by 1, I don't really need to write that, and it's going to throw me off if I don't get rid of it, so I'm going to get rid of it right now. And now I need to get it into standard form. So to do that, I need to multiply this out. Kind of cool that we don't actually need to multiply it out. You can actually jump to the answer. You could tell this is going to be x squared minus 8x plus 16 right now, since we did all those fancy expanding forms. You could do it with a Pascal's triangle. You could do it with sum of a square, essentially. In this case, it'd be a difference of a square. But if you wanted to go the long way back from Unit 2, and we did it back in Unit 2, we would write this as x minus 4, not squared, times another x minus 4, then plus 2 at the end. We would do the double distributive property. X times x minus 4, minus 4 times x minus 4, still plus 2. Then we would double distribute. X times x is x squared. X times negative 4 is minus 4x. Negative 4 times x is negative 4x. Negative 4x times 4, negative 4 times negative 4 is negative 16. And we can see that, yep, if we combine like terms here, we do end up at y equals x squared minus 8x plus 16, but got more like terms to combine, so we'll make that an 18. And that'll be it. So there we are. We're in standard form. All right. Number 12, path of a projectile is launched from a 32-foot tall platform. It's modeled by this equation. Graph the equation, then find the max height reached by the projectile. So we know from the equation that we're starting at 32. So we'll put our starting point at 32 here. If we want to find the vertex next. So again, we can do this either by literally graphing it or just doing x equals negative b over 2a. In this case, b is 64. A is negative 16. So this is going to be negative 64 over negative 32, which is just regular 2. So I know that at 2, that's going to be my axis of symmetry. That's a really bad straight line, but we'll work with it. And then I would need to plug 2 into the equation. So y equals negative 16 times 2 squared plus 64 times 2 plus 32. So y equals, this is 4. I know 4 times negative 16 is negative 64. This is 64 times 2. I'm kind of lazy, so I'm going to write that as 64 plus another 64. The reason I'm going to do that is now these two 64s cancel out. So that's a little bit of a mental math trick. This is going to be y equals 96. So I can put my point at 96, which is all the way up here. My last point, I'm ready to reflect across the axis of reflection. So I'm 2 to the left, so I need to go 2 to the right. I can make a little parabola. I don't like that one. I'm going to make a new parabola. That's a little bit of a better parabola. So there's my parabola. I could keep going down. I guess this one's a projectile, so it should probably stop once it hits the ground. There we go. And that's what we got. So that's number 12. For 13, use quadratic regression. Just throw it in the calculator. 0, 1, 2, 3. So let's make the table. 0, 1, 2, 3. 38, 41.5. 43.1. 41.9. All right, we type in our little code, y1 tilde ax1 squared plus bx1 plus c. So I can make them all capital. If I want to make it look pretty, I can hit the little magnifying glass. It looks like a nice parabola. But what we're really interested in is just our values over here. Because those values there are just going to tell us what the a, b, and c are. And once we know what a, b, and c are, then we can write the whole equation. So the equation ends up being y equals negative 1.175 x squared, because that's a, plus 4.855, because that's b. This gets an x, and then c is 37, so plus 37.955. And that's it. If you're using your TI calculator, this is where we would throw this into the stat plot menu. So you'd hit stat, enter, type in all the data, stat over, and then I think it's number 5 for the quadratic regression. Press enter a few times, and your A, B, and C should pop out. So that's it for number 13. Number 14, we need to solve this equation. So again, we can do this by hand. We could do this on our graphing calculator. If you do it on the graphing calculator, you want to make sure that you put this in, make that equal to y, and then y equals negative 48, and find where they cross. This one's actually, I think, going to be a little easier just to solve by hand, adding x squared and subtracting 8x to both sides. Might seem a little weird, but I just really like x squared to be positive, so that's why I chose to move two things over instead of one thing. So minus 8x minus 48. And this time, since x squared is just regular x squared, when I do the t-chart and find things that multiply to negative 48, add up to negative 8. All right, I knew I was getting close, but they cut me off. But anyway, negative 48 and negative 8. 12 and 4, those are the numbers that work out, because 12 times 4 is negative 48. So we have negative 12 and positive 4. Oops. Don't want to put the plus sign there yet. So times 4. Negative 12 plus 4 is negative 8. So we can write that, since this is x squared just by itself, x minus 12, x plus 4. And then we can use the zero product property. 0 equals x minus 12, so plus 12 both sides. So 12 equals x. That's one of the answers. And then for the other side, we have 0 equals x plus 4, so minus 4 both sides. So negative 4 equals x. Notice there are no y's. If you do put the y's down, you did it wrong. You used the graph and you didn't do the graph correctly. So you don't really get any points for that because you didn't actually do it right. You need to make sure that it's only the x values here. If you put the y values down, it shows that you fundamentally didn't get the question what it was asking for. So I'm going to be very picky about that. So just make sure that you're actually solving the equation for the x's, because that's what it's asking for. 15 says identify the intervals on which our function y equals x squared minus 2x minus 8 is positive. So the nice thing here is we did this one graphically. So what we're going to do is make the graph and just look and find out where we're above the y-axis. So x squared minus 2x. Get rid of the table. And that's the last part that we have. Minus 8. All right, we're still way zoomed out. So let's go back home to look at our graph. We still need to move a little bit. Let's zoom out one more time. All right, so we can tell that between these 2 points we're negative, and on the two sides then we're positive. So let's go ahead and grab that. And we'll do our analysis right here. That's a pretty big graph. We don't need it to be that big. So we want to find out where it's positive. Don't need to grab both of those. All right, so we can tell where it's negative. Bar chart. So we're definitely negative down here. This is the negative section. So we do not want to pick that part because positive would be up here. Because when we're positive, we're above the x-axis. Negative would be below. We do not want negative. So we are positive on this section, and we're positive on this section. So those two sections would be starting from negative infinity until we get to negative 2. So it would be the left side. And then we would go from 4 out to infinity, because that would be the right side. And then that's it. So those are the intervals that were positive. For 16, use square roots to solve the equation over the complex numbers. Seems pretty easy. We just use square root. Now I have to break down the square root of 196. Well, I know I'm going to get plus or minus. So if we break down the square root of negative 196, well, the first part's easy. Negative 1 and then 196. So I'm definitely going to get the I. But square root of 196, so I have to think, all right, well, what from that chart will actually work? So I could try 4. I think 4 might work. Let's see if 4 works. We'd have to do 196 divided by 4. So that would be 19 divided by 4 is 4. 36 divided by 4 is 9. So 49 works. This is 2. And then square root of 49, well, wait, I don't need to break that down. I know that one. That's 7. So I'm going to get 2 times 7 with the I. But 2 times 7 is going to be 14. Now you might have saw that as 196 already and just jumped right to the answer, and that's totally fine. But that's what we get. For 15, write this product in the form A plus BI. We're just going to use our regular double distributive method here. Again, you don't have to. There is a trick to this one. You could use the form a minus b times a plus b and jump right to the answer. You know it's going to be a squared minus b squared. You know the answer is going to be 29, but we'll just do it out. So 5 times 5 minus 2i. Oops, 5 plus 2i. And then minus 2i times 5 plus 2i. We can double distribute. 5 times 5 is 25. 5 times 2i is 10i. Minus 2i times 5 is minus 10i. Minus 2i times 2i is minus 4i squared. Combining our like terms, it's clear that that's going to be 0. Those are going to cancel out. So we get 25. And then we also see over here, we've got the one substitution we need to make with the i's. We have an I squared, which is negative 1. So we got 25 minus 4 times negative 1. But 4 times negative 1 is just going to be regular 4. So we get plus 4, which is 29. That's a little unsurprising because we kind of knew it was going to be 29 already. But if you want to do it all out, that's how we would do it all out to get to 29. All right, 18, we're at our quotient in the form a plus bi. So this is where we want to multiply by the complex conjugate of the denominator, both the numerator and the denominator. So the complex conjugate here, instead of 3 minus I, is going to be 3 plus I. On top, we can quick distribute. 7 times 3 is 21. 7 times I is 7i. On the bottom, we can use the multiplication trick. This is a minus b times a plus b. That's going to end up being 9 plus 1. Well, I guess I'll write it how we should write it with the trick. 9 minus I squared. We know I squared is negative 1. So 21 plus 7i over 9 minus negative 1. 21 plus 7i over 10. And again, you can leave it like that if you want. I know a lot of people on the test were writing it as 21 over 10 plus 7 over 10i. Yeah, that's how Savas wanted you to do it too. So if you wanted to write it that way, you can. And that's it. That's our final answer. So I'll take either this one. That one looks good to me. I'll take that one. That one looks good to me. If you do want to see this one drawn out, we can draw that one out also. So 3 times 3 plus I. And then minus I times 3 plus I. So 3 times 3 is 9. 3 times I is 3i. Negative I times 3 is minus 3i. Negative I times I is minus I squared. And just like the last one, this time these ones end up being 0. Again, these ones should always be 0 in the dividing. They won't always be 0 in the other one, but this time they're always 0. So this is going to be 9 minus I squared, and then now we've kind of joined up with the rest of the problem right there. So if you did want to see those denominators multiplied, if you don't like using the a minus b times a plus b trick, that's what you would have to do. All right, for 19, factor this expression. So again, this is one that's in the form of a squared minus b squared. So if I square root each of them, I'll get 9x for the first one. If I square root 25, I'll get 5. And we want to take advantage of the fact that a squared minus b squared is a plus b, a minus b. So we're going to go ahead and just use this as 9x for the a's, and then plus 5 minus 5. That's it. We're all set. We don't need to do the whole long drawn out thing. We can if we really want to. You can multiply 25 times 81, find things that multiply to whatever 25 times 81 is, and then they would have to add up to 0 because there's 0x in the middle, and then kind of work your way backwards from there. So you could do it that way if you really wanted to, but we want to use the trick. The idea is to use the factoring trick. For 20, functions defined by this equation, y equals 2x squared plus 16x plus 30. Which statements are true? Select all that apply. All right. So looks like first thing we want to do is look at the range. We can't do that yet because we don't have it in vertex form. All right, so I guess the first thing we got to do is get the vertex. So I guess we're checking C first. So to get the vertex, we say that x equals negative b over 2a. So that's negative 16 over 2 times 2. Negative 16 over 4 is negative 4. All right, so far so good. We got negative 4. We got negative 4. These ones would both be with negative 4, so everything's looking good so far. This one we have no info yet, so even that one's looking good still. We got to plug this in now. So y equals 2 negative 4 squared plus 16 times negative 4 plus 30. So y equals 2 times 16. Well, 16 times negative 4 is minus 2 times 16 plus 2 times 16 plus 30. Again, I'm kind of splitting it up so I can do it in my head a little easier because I know those would then cancel. So 2 times 16 is 32 plus 30, so y equals 30, not 32, 62. 32 plus 30. So y equals 62. Is that right? That's not right. Hang on. We don't want to get 0. I'm too used to getting 0. This should be another minus 2. There we go. That makes sense because negative 4 would be negative 2 plus negative 2. Not negative 2 plus 2. All right. So anyway, oops, y is going to equal, so negative 32 plus 30 is minus 2. Okay. So this does work out. This does work out. This no longer works out. Here I got negative 2, and this one's talking about 2, so that doesn't work out either. All right, so it looks like we're pretty set. It looks like we want to pick B and C, so I'm going to go ahead and pick B. And then I got to pick C as well. But hold up. Wait a second. We have one more word to check out. This says we have a maximum. But our equation is even, and the leading coefficient is positive. Well, wait a second. If we have even exponent and leading coefficient is positive, that means our parabola swoops up like this. We would have a minimum. We would not have a maximum. So it turns out we don't pick C. Oh, that's a pretty tricky one. So that's what we got. Is only B. Only B works out. All the other ones kind of cancel each other out. Again, you're more than welcome to graph that one if you want to graph it to double check it. You'd want to graph the original expression. That would clearly get rid of C and D. Then you have to see if A or B work out by graphing A and B also. It's kind of a fun one that's got a maximum. Usually don't see that too much to try and trick you with the maximum versus minimum, but this one did. 21, we need to solve, give an exact answer, so we cannot graph this. Graphing will not work for an exact answer. So we've got kind of a couple options. Factoring looks like it's out. I don't know anything that multiplies to 3 and adds up to 5. So we can complete the square. Wouldn't pick completing the square. 5 is an odd number. That seems like a disaster waiting to happen. So we're kind of left with the quadratic formula, but we've done that a lot, and it always works. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So b in this case is going to be 5. So negative 5 plus or minus the square root of 5 squared minus 4 times a. A in this case is going to be 1 because there's 1x squared. And then c, I already used blue. C is going to be 3 all over 2a. So 2 times 1. All right, we try and simplify as much as we can. So in this case, it's going to be negative 5 plus or minus the square root of 25 minus, that's going to be 12 over 2. 25 minus 12, negative 5 plus or minus the square root of 13 over 2. And then we double check because we want to try and break down square root of 13. All right, so the first one we check is 4, but we can't divide by 4, so that's out. And we check 9, we can't divide by 9, so that's out. 16 would be next, but we're too big, so we actually can't break that down. This is actually it. We're actually done at this step. So kind of nice that we can just stop right there. All right, 22, same exact idea, solving it the same way. We're going to use the quadratic formula. So just go ahead and throw in x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, we can grab b. So x equals negative 4 plus or minus the square root of 4 squared minus 4 times a. A in this case is not 1, so that's kind of cool. I guess that's different. A is 2. C is going to be 11 in this case. This is all over 2a, so 2 times 2. Okay, that makes this one a little bit more fun that a is not 1. All right, sounds good. So x equals negative 4 plus or minus square root of 16 minus 4 times 2 is 8. 8 times 11 is 88. All over 2 times 2 is 4. So we simplify this. Negative 4 plus or minus the square root of 16 minus 88. That one's actually giving me some trouble right now. So 88, 78, 72. Then 4. And then just like the last one, we try to break down the square root of negative 72, which that one definitely breaks down because I see it's got the negative sign in it. So I know at least I can get an I out of the deal. Then I've got 72. I have to think, all right, well, what can I divide 72 by? Well, if I'm not sure, start again at 4. So we try 4. Is 4 going to work? So if we divide 7 by 4, we'll get 1, carry the 3, so that's 32. 32 divided by 4 is 8. So, okay, that worked out. So we got a 2. I still have this 18, though, so I might be able to break this down again. 4 isn't going to work this time. However, the next number we would try then would be 9. And 9 does work. Square root of 9 is 3. So it turns out we have negative 4 plus or minus 3 times 2 times I times the square root of 2. Square root of 2 is still left over, all divided by 4. So we would simplify that to negative 4 plus or minus 6i radical 2 over 4. Now, if you didn't simplify that any further, I would be okay with that. Notice that you can simplify it a little bit further. You can divide everything here by 2. So we could break it down to negative 2 plus or minus 3i radical 2 over 2. So notice this 2 does not get simplified along with it. And if you even wanted to go even further, like you did in Savas, we could even make this negative 1, divide 2 and negative 2, plus or minus 3 halves I radical 2. We could go all the way to either one of these steps as well. But again, I'm pretty happy with this one here. If you can get down to here, that should be pretty good. Just be aware, though, if this one is a multiple choice question, this is what could be what the multiple choice answers look like. So you do have to be able to simplify down from that final answer there. 23, we had a question like this on the Unit 2 test. We're still in the Unit 2 section. What values will cause this equation to have one real solution? We have to remember that one real solution is when, not b equals 0. That'd be too easy. The answer would just be 0. When d is equal to 0, when the discriminant is equal to 0. So we need to use the discriminant equation. D equals b squared minus 4ac. Nice thing is this is a lot like the quadratic formula. Plop in 0 for d, and then all of our values for everything else. B, oddly, is just going to stay as b. Make that a little b to show I did do a substitution. That's not a 6, it's a b. A little tail, I guess. I don't know. A in this case is going to be 2. So 4 times 2. C is going to end up being 18. So 4 times 2 times 18. So that's going to be 8 times 18. All right, so let's go ahead and do that by hand real quick. So 64, 144. Sounds good to me. 0 equals b squared minus 144. Add 144 both sides. So 144 is equal to b squared. Square root both sides. And plus or minus 12 is equal to b. So notice we do get two answers here. Again, the two answers is because our parabola could be pointing upwards or pointing downwards. That's why it would make sense to get two answers. All right, for 15, solve 5x squared minus 7x plus 2 equals 3x plus 5. Give answers at 3 decimal points. That 3 decimal points is a good key that we should just throw it into the graphing calculator and see what we get. So when we solve this one, we want to split it up into 2. 5x squared minus 7x plus 2. And then we're using the other side, 3x plus 5. Again, sometimes we get two answers, sometimes we get one answer, sometimes we get no answers. In this case, we do get two answers. Let's go ahead and grab that. It's wrong button. All right, so we got our two answers. Again, like I said, sometimes it's only one, and sometimes the answer is no solution. But in this case, we got two answers. And again, since we solved it with a graph, we have to be careful. We have to look and ask ourselves, are there any y's in this question? There are no y's in this question. So the two answers are x equals negative 0.265 and x equals 2.265. Those are my two answers. That's it. That's all we want to do. That's it with 24. All right, 25, E-man used row operations on an augmented matrix representing a system of equations and obtained the following result. How many solutions does the system of equations have? Well, this is kind of weird because we had a question like this before. This was like from Unit 1. It's kind of sneaking itself all the way over here. But that's okay. However, when we did it before, we had it in row-reduced form. This is not in row-reduced echelon form. So we actually need to go back to our matrix calculator and put this in row-reduced echelon form before we can do anything. So let's see, we need to actually shrink our matrix. I forgot all my numbers. 6, 12, 6, 12, 24, negative 1, negative 6. All right, so this gives us our result. And so we know what the answer should look like. So now we know what the answer is. So the answer is this matrix right here. But we need to reinterpret the matrix to answer the question, because the question asks how many solutions. So to reinterpret this matrix, again, we look at the top. The top says that 1x equals 2. So x equals 2. The bottom line tells me that 1y equals negative 1. So y equals negative 1. So we have just one solution to negative 1. And that's the answer. So there's only one solution. So remember, the options that you have here is there could be one solution. There could be no solutions. So no solutions would be if you got 0 equals 0. Or sorry, 0 equals like a number. And then we could get infinite solutions. That's pretty cool. So that would be if we did get 0 equals 0, then we would have infinite solutions. So those would be the other two options we could get. We didn't get that. We got x equals a number and y equals a number, which means one solution. All right, 26, another use a graph to solve. Your graph will be scored. So again, kind of seems like we're doing some Unit 1 stuff right after Unit 2, but it's good to kind of split up all the graphing. We'll do each side separately. So here we have absolute value of x plus 3. Here we're counting by 1, so 1, 2, 3. And our slope is going to be 1, so that'll be kind of nice. All right. Other one I have here is x squared plus 1, so I'm going to go up 1. And then I'm just going to go ahead and plot my parabola. I know I need to go 1 over, and then over 1, 2, 3, over 1, 2, 3. So we're going to go ahead and plot the parabola. And this one's kind of cool because in this case, we also got 2 answers. So those 2 points where we connect are going to be right here at -2 and 2. Again, there's no y's in the question, so we don't give any y's as answers. That's it. Kind of a fun one. Again, you can graph that in Desmos or your graphing calculator if you wanted to double check, but we'll just graph it with the transforms here. For 27, what's the vertex of the graph of this function? To get the vertex, we'll use the formula x equals -b over 2a. So -4 for b over 2. This time 1 is a, so 2 times 1. So we get 4 over 2, which is 2 is the x coordinate. We plug 2 into the original equation, so y equals 2 squared minus 4 times 2 minus 5. And this time the numbers are small enough that I can just multiply everything out. 4 minus 8 minus 5 is -4, -9. So our answer is going to be 2, -9. Again, that's another one that if you wanted to graph in Desmos to look at it visually, you could solve it visually with Desmos. 28, use the binomial theorem to expand a plus 3b to the 5th power. So to solve this one, we have to use Pascal's triangle. So that's kind of fun. So we'll make a triangle, 1, 1, 1. 1's on the side, 1 plus 1 is 2. 1's on the side, that's a really bad one. 1 plus 2 is 3. 2 plus 1 is 3. I know I need to get the row that starts with a 5 as the second number. So 1, 1, 1 plus 3 is 4. 3 plus 1 is 4. 3 plus 3 is 6. This is a 4. I need a 5. Even though I've got 5 rows, I need to go one more. So 1's on the side. 5, 5, 4, and 6 is 10. 6 and 4 is 10. We'll write out each of our parts. So this one's first. So that one gets to go first. I get my number first. So 1, a to the 5th power. And then there's no 3b's in the first one. Because remember, first one it would be to the 0th power, so we don't need to write that. Second one, though, is going to be a 5 at the start. Our a's are going to go down by 1, so 5 to 4. And now is where we introduce our 3b's. And that goes to the 1st power. All right, next I got a 10. A's are going down. 3b's are going up. And next, I got another 10. A's are going down. 3b's are going up. Next, I got a 5. A's are going down. 3b's are going up. And last, I got a 1. A's are going down, so since I get to 0 A's, I don't need to write them, so I'm not going to. 3b's are going up. All right, so that's what we got. Now, this isn't the final answer because we still have all these coefficients that we can simplify. So let's do that. So we get 1a to the 5th, which I don't need to write the 1, so let's make this really simplified. A to the 5th. Next one here, I've got 5 times a to the 4 times b, 3b to the 1st. So that would be 5 times 3 to the 1st, which is 15. Because 5 times 3 is 15. A to the 4th, b to the 1st. So my letters are going to be in alphabetical order. Next one here, I've got 3 squared is 9. 9 times 10 is 90. All right, next one I got here is I've got 3 to the 3rd, so that's 27. 27 times 10 is 270. A squared b to the 3rd. So even though there's more b's, I'm still writing the a first because it's in alphabetical order. 3 to the fourth would be 81. 81 times 5 is 405. Since I'm just doing a to the 1, I guess I wrote b to the 1, so I'll write a to the 1. I don't really need to. I should probably dump those ones. Yeah, I'm going to do that. We can just make it b and a. Yeah, so I got rid of those ones. And then we got the last part. I probably should have checked out what the last part was going to be before I started, but we'll go for it. So we got 3b to the fifth. So I need to figure out 3 to the fifth. So that's 81 times 3, which is going to be 243. All right, that wasn't too bad. B to the fifth. And now I've got all of my terms. 1, 2, 3, 4, 5, 6 terms. That makes sense because we start with a fifth power, so we should end up with one extra term. The highest power of a's is to the fifth. Yep. The highest power of b's is to the fifth. Yep. And if we add all the exponents, 4 and 1 is 5, 3 and 2 is 5, 2 and 3 is 5, 1 and 4 is 5. Everything kind of checks out. So that's what we got. All right, 29, we're doing some synthetic division. So for synthetic division, we have this x minus 2. Remember, we need to solve that first before we can do synthetic division. So x equals 2. 2's going in the box. So 2's in the box. So we have to take our whole expression and see what we're dividing by. We got 7x to the thirds. We've got negative 9x squareds. We've got 2 x's. And we've got just 18. Now this was nice. There were no zeros in here, so we didn't skip any terms. So we didn't need to add any zeros into our synthetic division. And let's see what we got. So we bring the first number down, and we're going to multiply. 2 times 7 is 14, and we add them up. We get 5. 2 times 5 is 10. All right, then we add them up. We get 12. 2 times 12 is 24, and then we add them up, and we get 242. All right, well, a little inconvenient, but that's okay. We don't always have to get 0 at the end. Only if it works, we're going to get 0, so this doesn't divide cleanly. So that means what our final answer is going to be then is it's going to be 7. We started with x to the third, so we drop down 1. So 7x squared plus 5x plus 12 plus, and then remember the last one's going to be 42 divided by x minus 2. So the x's have to go on the bottom because we had no x's. So if you lose 1, you're at minus 1, you're down here. That's what we got. So this is one of the rare questions where you have to solve it this way because it does tell you to use synthetic division. So if you don't use synthetic division, you haven't done the question correctly. You didn't do what it asked of you to do. So just pay attention to that part. For number 30, find the zeros of this function and then describe the behavior of the graph at each zero. So if we have to find the zeros of the function, we probably are going to think about using maybe some p's and q's in order to figure out what our rational root theorem tells us we're going to get. But usually when we do that, we go to a graph anyway just to see what the first good guess would be. So what I want to do is I actually want to graph this first. So let's graph it and see what we get. So x to the third plus 3x squared minus 4x minus 12. All right, let's go home. And it looks like I got a plethora of good guesses here. It looks like I might actually have all the numbers because we know it's an x to the third, so we should have 3 answers. And we got 3 answers right there. It looks like we're done. Okay, I guess we didn't really do that much on this one. On this one, we could have just graphed it. Sometimes we get lucky. We'll take it. All right, well, we'll find all the zeros. I guess we found them all. The zeros are x equals negative 3, negative 2, and 2. Now notice, again, I know I'm done because fundamental theorem of algebra says I need to get 3 answers. I've got 1, 2, 3 answers, so that's it. I didn't actually need to do any synthetic division or trying to find out any p's or q's or anything. That was pretty nice. Describe the behavior at each zero. So at x equals negative 3, this is crossing. That's a cross, so this is a cross. We go through the x-axis. At x equals -2, that's another cross. We go through the x-axis, and then over here at 2, we cross again. So no bounces, no touches. Again, that would be the other situation, whereas if we were to have something that looks like this, we would say at x equals 4, this would be a bounce or a touch. That would be the only other option we could have. I'm not going to put it down here because this isn't actually part of the question. This is just a little extra aside for your reference. All right, 31. What are all the real and complex solutions of x to the third minus 4x squared plus 9x equals -6? Round to the nearest tenth if necessary. All right, so round to the nearest tenth if necessary, but it does also ask for real and complex solutions. So part of it's saying, hey, you need to go to the graph, and part of it with the complex is saying you need to do it by hand. So it seems like we have a little bit of a mismatch here with the question. So let's start off by moving this 6 over to the other side. So this gives us x to the third plus 4x squared plus 9x plus 6 equals 0. And let's see if we can get one of the solutions, because again, we're supposed to have 3. And our complex solutions have to come in pairs. So there has to be at least one real solution. So there should be at least one on the graph. So let's see what the graph gives us. I totally forgot what I was doing. 4 and then 9. I think there's a 6 involved over here. Edit. X to the third, 4x plus 9. Okay, yeah. Okay, so we do have 1 right here. So that looks pretty good. I don't see any others. So since I don't see any others, that means that it probably is going to be a hybrid question. We did a little bit but with the graph. Now we got to do a little bit by hand. So our little bit by hand is we can tell that one of the zeros is x equals -1. That's not -1 at all. So we got that one. There should be 2 more though. I didn't see any on the graph, so I'm thinking they might be complex, or it's possible they could be at like 15. I mean, I didn't really zoom out that far. But I don't feel like I want to zoom out that far. I feel like now that I know -1 is a solution, I've got 1x to the third, I've got 4x squareds, I've got 9x's, and I've got regular 6 as my number. So again, I'm not using this -6 up here. I'm using the regular 6 because that's in my equation. As long as the graph didn't lie to me, I should get 0 when I do this. -1 times 1 is -1. Add them up, we get 3. -1 times 3 is -3. Add them up, we get 6. -1 times 6 is -6. Add them up, we get 0. So that did work out, so that's good. So that means that my polynomial that I have, I dropped this down by 1, so I started with x to the third, so now I have x squared plus 3x plus 6. Remember the x minus 1 did work, so this is going to be x plus 1. Again, I'm switching the sign because, again, we always want to switch the sign if we're dealing with the x's. But that means I need to try and break this down a little bit. So if I try to factor it, I don't know anything that multiplies to 6 and adds up to 3. So I'm out of luck there. You know what? I got 3 numbers. We said in class, if you get 3 numbers, just go ahead and use the quadratic formula. Might not be the best solution, but it'll always work. So let's just go for it. So this is A, B, and C, which is the other nice thing is that they're always right in the right order. So, all right, -b plus or minus square root of b squared minus 4ac all over 2a. This is like the third or fourth question we did the quadratic formula with. Guess we should definitely have that memorized. All right, well, -3 plus or minus square root of 3 squared minus 4 times a in this case will be 1. C in this case is 6. All over 2 times 1. Okay, all right. We start to simplify. Negative 3 plus or minus the square root of 9 minus, that doesn't really look much like a 6. We'll make that more 6-like. 9 minus 24 all over 2. All right, 9 minus 24 is negative 15. Yeah, because 15 and 9 would be 24. I have to break this down. There's a negative, so negative means I got to break it down. So square root of negative 15 is going to be negative 1 and 15. So that's going to give me an I. 15, I can't divide it by 4. I can't divide it by 9. 16 is too big, so that's what I leave it as. Okay, all right. Well, that was not too bad. So this is going to be x equals negative 3 plus or minus I radical 15 over 2. And it looks like we're done. But again, we have to remember, we did have our one real solution. So don't forget about negative 1. Our negative 1 over here still gets to hang out at the end. That's part of the solution. So we're going to go ahead and just transfer this one also all the way down into the answer right there. And does that work out? Well, let's see. We wanted to have 3 solutions because we have x to the third. We've got 1, 2 for the plus, and then 3 for the minus. So we do get 3 solutions. So that's pretty good. That follows all of our theorems, and that's nice. It's cool. Really good use of the fundamental theorem of algebra to double check that we're done. All right. And that's it. That's it. I guess that's it. Nice. Okay, that was really good. I want to do a couple more things. I really like synthetic division, but I guess we're done. So that's it.